have them. You'll need it for the second proof we do today. All right, so let's do this. First, before I show you methods 3 and 4, what the heck were methods 1 and 2 yesterday to prove triangles congruent? So if you want to prove triangles congruent, I got Lucy, two methods from yesterday. Perfect. Side, side, side. Side, angle, side. Everyone remind me, what do you need to know about the angle? It has to be in between, and if it's not, the triangles are not congruent. We do not write SSA on our paper. If the angle's not in between, they are not congruent. Story's over. All right, so what if they're not either of the two I showed you yesterday? Here's two more out of the 5. The 5th one coming after the quiz. Method number 3, ASA. ASA, I'm sure you can guess what it stands for. Angle, side, angle. And based off our work yesterday with side, angle, side, and angle, side, angle, what do you think you got to know about the side? It's got to be in between the angles. And we had practice with that yesterday, talking about what in between means. So yes, if you want to use angle, side, angle, the side needs to be in between. Well, what if it's not in between? It's still okay. If the side's not in between, it's still okay. You just have to use reason number 4 now. All right, if the side is not in between, fine, no big deal. The triangles are still congruent, but now we're going to use angle, angle, side. Bottom line, if you have 2 angles and a side, you're good. You're good. It's just a matter of picking which one do I need to use. All right, so 2 angles and a side is always good to go for triangles being congruent. It's just a matter of what method is it. All right, what method. So let's go over our first basic proof. Sorry, I didn't write in all the statements and mark your diagram like I did yesterday. Suck it up. I'll give you guys a minute to write in all the givens and mark your diagram. All right, so everyone has the angles marked. So first thing I always want you to say is, in the givens, how many pairs of parts, congruent parts, did I give you? All right, so in the givens, let's see, I gave you angle PSQ and RSQ, right? So we talked yesterday, maybe putting an A next to that, so that tells me you have 1 pair. So how many do we have to find on our own now? 2 more, right? We need to find 2 more pair on our own, no? No. Yeah, but I actually have to write that. That's what I'm saying. But what I actually wrote for you is only 1 pair of congruent parts. I know I gave you the bisector, but you guys are going to give me those parts. So really, you need to come up with 2. Everyone in agreement? I need 2 pairs of corresponding parts that are congruent. Speaking of the bisector, let's use that first. If QS bisects angle PQR in an honors level class here at this point in the year, we should know what 2 angles are equal, I hope. All right, so give me what 2 angles have to be congruent because angle PQR is being bisected. That makes what 2 angles up here equal? Tiffany, what 2 angles have to be equal? Great job. Angle PQS has to be congruent to angle SQR. Awesome. Definition of bisects. And that gives me another pair of angles. And here's another reason why I like putting the A's and S's next to them. This tells me the next thing I find better be a side, because there's no such thing as AAA, and there never will be. All right, that is not a way to prove triangles congruent. So that at least tells me, oh, I found 2 pairs of angles. The next one better be a side. Better be. All right, because it can't be another pair of angles. All right, speaking of that side, where is it? Because I'm fresh out of givens. Right, I am fresh out of givens. Where's that side I'm looking for here, Theodore?
It is
Yep. I got a shared side, so I can count it as a full side. SQ, congruent to SQ. Reflexive. And I forgot to mark my bisected angles. Okay, so it looks like I have enough information. Now the key is, which method is it going to be? Angle, side, angle, or angle, angle, side? If you need help, cover up one. I always cover up one of the triangles, and I figure out if that side is in between the two angles I've already marked congruent. So triangle PQS congruent to triangle RQS. So ask yourself, is the side in between? If it is, it's angle, side, angle. If it's not, it's angle, angle, side. So what method you feel comfortable telling me here? There we go. Now we'll try that again here, Lucia. Good job. The side is in between. Good job. Okay, any issues there? Pretty basic, right? Pretty basic. You ready to raise it a little bit? A little higher level proof? Ready to roll? Let's do this. I'm going to go a little bit slower than probably you like on this proof. It's a little bit different than what we've been talking about. Let's look at the triangles I'm asking you to prove congruent. ACD and ECB. And this is going to start happening from time to time with us. You see they overlap each other. They're overlapping each other. And I don't know about you, it's going to be tough for me to see what sides belong with what triangle, what angles belong to what triangle. So yes, as some of you are starting to figure it out, that's why I gave you the colored pencils. Anytime we have overlapping triangles moving forward, let's highlight them so I can clearly see both triangles and their sides and angles. So take one pencil, highlight one of the triangles, take a different color, highlight another triangle, so I can see where these bad boys are. All right, are we ready? Okay, everyone sees them. All right, first up, let's go over the givens, because I always like to see, do I have any pair of corresponding parts? All right, DAC and BEC. So let's take a look at those two. Angle DAC is this top one right here, angle A, and angle BEC, which looks like angle E. Are those two full angles in each triangle? Are those two angles in each of the full angles, not partial? Are they full angles in each of the triangles you've highlighted? Yeah. Is everyone in agreement they are? I ask you that because now I can put, oh, I got a pair of angles available right now. Does everyone see why I put the A there? It is a full pair of angles in each triangle. All right, how about DC and BC? Well, let's take a look. Side DC, is that a full side in one of these two overlapping triangles? DC. Is it? DC.
Yes.
Yes, no?
Yes.
It's a full one in my green one, right?
Yeah.
It's a full one in my green one up here, right? I don't know what color yours is, but DC is a full side in triangle ADC. And let's go to, it's congruent to BC. Is BC a full side in one of the other triangles? Yes. Everyone is in agreement. So, again, I'm asking you that because I want to put an S there or not. Whoa! Look at this! You got two pair already. How many are you responsible for? 3. So you need to find how many more? 1 pair. I don't know if it's going to be sides or angles. I can't tell. But you are on the hook for only 1 more pair of corresponding parts. Go ahead, talk it over in your group. I don't want to say any more. Where are they? Where are they? Hey, whoa, sorry, whoa. Before you talk, I should mention this. It's got to be full sides or full angles. Like for instance, every year I get, hey, let's do the vertical angles because vertical angles are congruent. That is true. If you put it in your proof, I'm not going to mark it off. But are those vertical angles full angles in those triangles? No, so it means squat to me. It's not going to help me. I need full angles or full sides in both triangles. Now you can go ahead and talk to your group.
Those two. And
Don't overthink it.
Angles define ADF.
Probably want to find an angle like
Just say angle C.
Yeah,
angle C. So you do a his house.
So,
She
seems like a lot.
And then triangles are congruent.
I need full sides or angles. Those vertical angles won't help me. They're not actual angles in the triangles. Think you got something? And if you don't, I think the problem is everyone always just thinks this is used for sides. Because we've always used it for sides. We've never actually used it for a pair of angles. And that's where we're going to use it here. And that is those two triangles share a full angle. Don't they? They have an angle in common. And where is it?
C.
Angle C, yes. So reflexive can be not only be used for a shared side, it can be also used for a shared angle. Everyone see it right there. Angle C is shared in both triangles, so we can use it. As long as it's a full angle, we can count it. Angle C congruent to angle C. Ooh, whoa, whoa. Tough part hasn't even happened yet. Tough part hasn't even happened in this proof yet. So that gives me another pair of angles. Here's the tough part. Because I see a pair of sides and two pairs of angles. The tough part is figuring out what method it is. That's, I think, the toughest part. I think a lot of you could find angle C being the reflexive angle, but now it comes down to, ooh. And I don't want you to guess either. I want you to be confident what the method is. So we have to figure out, we got to figure out, is this side in between or not? Now I get it. Look, I'll be the first one to raise my hand and be like, that thing looks nuts to me up there. So what I do, I separate one of the triangles and draw it out separately. Watch how easy this becomes. I'm going to take BEC and draw it out right here. And I'm going to put any marking we put on BEC and watch how easy this becomes to distinguish if it's angle side angle or angle angle side. Everyone agree I marked angle E with an arc mark? And I marked angle C with 2 because that was reflexive. And what side did I mark with the hash mark on here? BC, BC, right? I marked BC with 2 hash marks. That side in between? Is this side in between the 2 angles?
No.
That's pretty easy now. A lot easier than looking at that magic eye diagram over here. All right, so angle, angle, side. So draw it out and mark all the markings to see what it is. Okay, take your packet, close your packet, flip it over to the back where there's a blank page on the very last page. This proof is not contained in your packet. I don't think it is anyway, right? Because you guys, that was the last proof of today, right?
Yeah.
Okay, you're going to draw the following. So this is a 7-stepper. I'm not saying a word. I will also give you a warning. Some of those theorems we used from Unit 2 that were on that cheat sheet you used are coming back. So I don't know if you have that sheet you want to look at. You can if you want. But here you go. Beast up here. When you and your group, not you individually, when you and your group think you have it, let me know. Or if you're just stuck, I will happily help you out. Okay?
Got it.
But I will let you know it's 7 steps.
Got it.
I'll never tell you that on a test or quiz, but I want to give you a shot at this. That it's 7 steps. And you're still proving triangles congruent, so you got this. Dig deep, honors kids. This is like the challenge. I want it. I'm hungry for it. I'm going to show him it's actually not as beefy as he says it is.